Hey, it's Kevin Chang, and this is the Soniclast Plastic Pitch MIDI Microtuner. In this video, I'm going to walk through using the plastic pitch. Be sure to check out our other videos about other aspects of the plastic pitch. I'll put a link in the description for a playlist. Also, be sure to subscribe or follow us, and there is also an email newsletter at soniclast.com. So the basic idea of the plastic pitch is that there's a controller that sends MIDI into the plastic pitch. The plastic pitch does its magic and sends MIDI out to a synthesizer. And then what you hear coming out of the synthesizer is the microtuned result of the plastic pitch. Notice that the plastic pitch has 3 MIDI inputs, 3 MIDI outputs, and also a USB MIDI input and output. So you can easily send MIDI from multiple controllers into the plastic pitch and send MIDI out to multiple synthesizers from the plastic pitch. In this case, having 3 inputs and 3 outputs makes it easy to have, for example, bass, melody, and harmony all tuned together at the same time. So for the purposes of this video, I just have one controller and one synth. So the first thing to notice on the plastic pitch is that it has a screensaver, so you wake it up by turning a knob or pressing a button. So you'll notice here when I turn the knob, it cycles through the different options. There's also a forward and a backward button, and that lets you navigate as you would expect. So on the home menu, there are 4 submenus. There's tuning, scales, settings, and MIDI utils. So we're going to start with tuning first. This screen shows all the numeric values that are used to calculate the microtuning that the plastic pitch is doing. So up in this top left corner, you'll notice it says 200, and that is the range in cents. And that goes all the way from 0 to 200. And that is a global control for these 12 tuning knobs. So for example, if I tune E, I can go up 200 cents, and I can go all the way down to minus 200 cents. So this is what that sounds like. But if I set the range to a different value, then it only goes up, it only spans that range. So I'll only go up 169 and down 169. So range can also be used to get back to neutral. So for example, if I play a C major triad and then tune and want to get back to neutral, I can do it like this. So the next value I want to talk about is the 1200 here on the side. So 1200 cents is a standard octave, right? So if I play C to C, that's 1200 cents. Or if I play B to B, that's your standard octave. But on the plastic pitch, I can change that. So if I want a wider octave, say I turn it up to 2400 cents, then now it will be 2 octaves is what you'll hear, even though I'm playing 1 octave. The other thing that happens is that instead of each step being a semitone, you now have a whole tone. And instead of a tritone, you have just 1 octave. And of course, you can set this to in-between values too. So like if I set it to 1902, That's actually an octave and a fifth. So I'm going to set that back to 2400. And we can talk about this value, which is the reference note. The reference note, C5, is the MIDI name for middle C. And the reason why that's important is that you know that middle C is middle C. Whereas if I play an octave below middle C, an octave of keys, that's actually 2400 cents below middle C, and over here is 2400 cents above middle C, or 2 proper octaves. Whereas if I change this to, say, C6, now this is the reference note. And if I play the key that is middle C, it's actually 2 octaves below the reference note, which is actually 1 octave below middle C. I don't know if that makes sense. It's a lot to follow, but just know that the reference note matters when you start, especially when you start changing the octave width. But there are other cases too when it matters. So the next thing I want to talk about is I want to return to these 12 knobs and talk about different ways of displaying the synths values. So you'll notice that when I highlight that space and change it, right now they're all zeros, and all the zeros mean that we are neutrally, each key is neutrally tuned. If I tune this, it's still neutrally tuned, but now you see the absolute sense values relative to the reference note. So right now C5 is the reference note, so this one is 0, and then this one is 200 cents up from that, and this one is 400 cents, 600, 800, and so on. So if I change this, you'll see that it changes the value relative to the reference note, being C currently. So you see it goes all the way up to 2200 here, and then when it wraps around, it goes back to 2400, it goes back to 0. So like if I turn this down, you'll see that it goes down. So this is useful for seeing how individual notes are in the context of the scale. The other way to think of the reference note is as the current key that you are transposed to. Say I tune the F up 200 cents, so now the F key will sound like a G. So now we know that playing a fourth will give us actually a fifth in sound. So the next thing I want to talk about is this field here, which lets you select scales. Right now it's blank, which means that we're in free tuning mode and we can tune all the different values. If I turn it to the right just a little, I get to a T, and the T stands for transpose. So the reference note is the currently transposed key. So right now we're in the key of C, and I still have C to F tuned like C to G. And so I can change the reference note. You can see now we're in the key of D, so if I play a fourth in D, it still sounds the same as a fifth, and that's because we just transposed the scale. You'll notice there's these little tick marks, and those little tick marks just indicate that the current tuning knob is out of sync with what's on the display. But when you transpose it, it shifts the values around. So like I can tune it to E5 now. So now E, we're in the key of E. So that's useful if you have a scale and you want to shift it around to different keys, transpose it. So there's another way you can do transposing. So this is transposing using this knob to do transposing, but the other way is by sending a MIDI note to the key that you want to transpose on a particular channel. So I'm going to change the channel right now. to channel 16, and I'm going to press D. So now we are transposed back to the key of D because I pressed D. I'm going to change back to channel 1, which is where I was playing. So now 6. Now I'm in F. So just to reiterate, what I did there was I changed to a different channel, which is defined within the configuration of the MIDI Microtuner. More on that later, but that channel allows me to send MIDI notes and then I can transpose to that key instantly. This is most useful if you set up 2 controllers, with one sending it on the transpose channel and one sending on the non-transpose channel, and then you can instantly transpose between different keys as you're playing. So then returning to this scale field, I can turn it and you'll see it goes from 0, counts all the way up to 31. And then it goes back to blank, which was the free tuning mode. And then back to 0, it just wraps around. So in scale 0, I currently have a quarter tone scale loaded. And you'll notice in the scale and also the transpose mode that you can't change the octave width. You can't select the octave width to change, and that's on purpose because you're assuming that you're working in a particular scale with a particular octave width. So if you want to change the octave width, you need to be in the free mode in order to change the octave width. So if I select 0, which is scale 0, which is loaded in the plastic pitch, this will quantize everything to a quarter tone scale. So like my F, which is tuned up 200 cents, you'll see that it changes by 50 cents or a quarter tone at a time. So I think that's all I want to say about the tuning screen, so I'm going to hit back. So the next submenu is the scale submenu. And I'm going to hit the forward button to go in there. And this is a scale browser, so you can see that I just talked about scale 0, which currently has a name, name me 00, which can be changed. I'll show you how to change that later. And you'll see there's a 24 here. That means that there are 24 pitches specified in the scale. That's the quarter tone scale, so there's 24 pitches across the octave. 1200 are the number of cents in an octave. In this scale, you can load scales that use non-1200 cent octaves, and then 60 is middle C in MIDI note number terminology, and that means that this scale is by default loaded with middle C as your reference note. And you can choose to activate it, which will take you to the tuning screen. And you'll notice that it loaded that scale up, and scale 0, and C5 is the root note. If I change this to like 62, that's going to be D5. So I can hit activate, and now we're D5 and we're scale 0. So this just gives you an easier way to browse the scales. And if you put a useful name in there using the configuration tool, which I'll show later, then it helps you keep track of what scale you're on. You can also save to in this. And what this does is it saves. So say I want to save the current scale. So we have this scale. And F is tuned up by 200 cents, so it really sounds like G. And so we want to save that scale. Then we browse to the scale number we want to save it to. So scale number 1, I'll do save to, overwrite, hit forward again. And now that scale is saved. So now we can activate it, and it's in 1, and you'll see that this is the scale that I just saved from the menu, and it's saved in here. And it can be transposed. So now it's in the key of D. So yeah, so that's the Scala browser. So I'm going to back out of that. I'm going to skip settings for now and go to MIDI Utils. So MIDI Utils, I'll start with the RX monitor. This lets you see notes. So right now this is showing that on channel 1, MIDI note 60, which is middle C, is coming in on port A. If I move this to B, you can see the notes that are coming in each port. And then U is USB, so if, like I said, my DAW to send notes in, you'll see it come up there. This is useful for making sure you're getting notes on the channel you're expecting on each of the input ports. So then program change lets you specify program changes to be sent out each of the output ports. Right now it's set to no, but if you set it to yes, then you can change the program on the synth that's connected. I don't know if you can see that. Yeah, you can see that. So it's flipping through programs currently. Right here, you can see it's. I'll go back to 0, which is where I was, or 1, which is where I was. So often the program number is off by 1 with, you know, what they're showing there. But these are raw MIDI numbers that you can specify the MSB, LSB, and the program number. And this is on a per port. So if I set this to, this is DIN Y and DIN Z and USB. So each one has its own set of parameters that can be configured. And this is useful particularly when you're working with multi-timbral synths and you want to change the program across multiple voices all at once. So for example, if I tried to change the program on the Tetra itself, I would have to go to each of the 4 voices and change the program for each of those 4 voices. This simplifies that because now I can change them all at once on here. And then the other 2 options in the MIDI util are all notes off, which this sends a MIDI all note off, which turns off any sounding notes. So if I play some notes and then hit forward, it'll do it. Right, so it turns off all the notes. This is useful if you get stuck notes for some reason. Sometimes synths misbehave and you need to turn off all the notes. The other thing, the other option, and that sends notes off in every single port. And then the final option is pitch bend RPN, which sends an RPN is a registered parameter number in MIDI terms. And there's a standard RPN number 1, which is reserved for setting the pitch bend range. So some synths don't respond to this, but some synths do. And so this, for the ones that do, this sets the pitch bend range to match how the plastic pitch is configured. If for some reason your synth doesn't support it, then you'll need to manually set that. I'll cover that in another video. But all that to say, all notes off and pitch bend RPN. The other way that you can send those is by holding down both buttons at the same time. So I'll show how that works. They're provided here in the MIDI util screen, but the reality is you just push both these buttons if you ever get hung note. And then finally, I'm going to talk about the settings screen. So this is the tuning timing. So if I set this to next note, then any tuning I do doesn't take effect until the next note. For example, and real time is what I was doing before, so that everything's immediate. And then the other setting that's here is the OLED time, and that's the timeout until the screensaver kicks in and it goes blank, which you've probably noticed it went blank a few times. And so if I set it really low, then it'll go blank after 3 seconds. So then the way that you wake it up is you either turn this knob or you push one of these buttons and it wakes up. So oftentimes I'll have it set around maybe 20 seconds, but for the demo I've had it set up all the way up to 120 seconds. So I've now shown you everything in the system menu. There are a number of other settings to be configured in the plastic pitch, and they're configured using the configuration tool, which I will show you next. So this is the plastic pitch MIDI Microtuner configuration tool. You can access it from our website, soniclass.com. You can also download it to be used when you're not connected. It runs in a web browser, but it doesn't have to be connected to the internet to work. So when you first start it up, this is what it looks like. It says please connect via USB, then click on the sync button. So of course I have my plastic pitch here plugged in via USB, and then when I press sync, it loads up all the current values that are in the plastic pitch. So there are these 5 tabs: MIDI input, MIDI output, global settings, scales, and extras. MIDI input and MIDI output are used to configure the input ports and output ports to work with a particular synth. I'm not going to cover that in this video. The parameters are specific to the kind of synthesizer you're using, so I'm going to cover that in great detail in other videos. So please look for those. So I'm going to start with the global settings tab, which you've seen some of these settings. You've seen the tuning timing earlier in the video, and that can be set to real time or next note. And you've seen the OLED timeout in seconds, which can be set from 1 to 120 seconds. I talked about earlier in the video, I talked about transposing using another MIDI controller, and so this is where you set the MIDI channel that gets used for that. So there's 2 kinds of transpose. There's absolute transpose and relative transpose. Absolute transpose is when you transpose to the MIDI note. So for example, your F key is actually tuned to G like I had earlier in the video, and you hit F, then you're going to transpose to the key of F. But if you use the relative transpose channel, it will actually look at the scale and look at what your key maps to and transpose to that. So if your F is actually mapped to G and you hit the relative transpose channel, then it'll actually transpose you to the key of G. Then the next thing here is the MIDI CC tuning incoming MIDI channel. So this is made so that you can automate the tuning on the plastic pitch. So you can send CC messages in from your DAW on this channel, and it will let you automate the knobs on the plastic pitch. This is the reference MIDI note. So this is, you saw this on the tuning screen earlier in the video. This is set to middle C currently. This is the sense width of an octave. This is 1200 cents, which is what we left it at. We also played with it at 2400 cents in the video. This is the sense display mode. So this is absolute versus relative. This is on the tuning screen when you switch between seeing the relative tuning of the pots and the absolute tuning of the pots, which is relative to the reference MIDI note. And then this is the currently active scale, which currently it's in free tuning mode, but if you pick scale 0 or whatever scale you pick, it will change that. So you can change these values. I should mention this. Like if you wanted to change it to absolute, then you just set it to absolute and then you just hit right. And then it's set that way on the plastic pitch. I don't have the technology to show the plastic pitch right now, but you'll just have to trust that that's what happens and it changes. And then the currently active scale. So that's all I've just covered all the fields here on the global settings tab. And then there's the scales tab, which shows the current scales that are loaded. And here's this is the, right now all 32 slots they were all initialized with the quarter tone scale. So you see here. But you can put your own scales in here. These are Scala files. This is Scala file format with a slight modification, but basically here's your quarter tone scale. So you'll see it counts by 50s all the way up to 1200. And this is a Scala file, except for this part right here is actually placed in a comment line in the Scala file. So it's still backwards compatible with Scala files, but this is the name that's currently being used. So say you want to call it like quarter tone, and then 60 here is the reference note, so that's middle C. So then if I write that, now if we look in the plastic pitch, that will be the name of that scale in the scale browser. And then this scale here, scale 1, is actually the one that we overwrote with the custom scale that we had created, where we took F and we tuned it up to G. So relative to C, F is 500 cents up. So you'll see that there's no 500 cents in this scale. It goes 100, 200, 300, 400, and then 500. We actually tuned the F up to G, which is 700. So now it's 700. So we actually got rid of the F from that scale, and there's only 11 notes in the scale that go from 1 to 1200. If we had tuned F to say like 550, then there would be like a 550 here. There'd be like a 550 here that you could see, and then this would be 12 instead, which we could write this, and then it would actually, now this is the scale that's in there for scale 1. So like I said, there's 32 scales possible. These are all Scala file format, so you can take a Scala file and copy and paste it into one of these fields, and then write it, and then it's saved to your plastic pitch, and then your plastic pitch will quantize to that scale as you turn the tuning knobs. And as you change the reference note, it will transpose accordingly. And then finally there's the extras tab, which the current firmware version is 1.01, and these are a number of utilities that we run to set up your plastic pitch. They're provided here in case you need to use them, but they shouldn't need to be run. Factory reset obviously sets you to initialized values, and this lets you calibrate the pots so that they match up with what you see. So this concludes the basic walkthrough. See you next time.